Welcome to this video. In this video, we are going to see about TCP protocol suite. TCP/IP refers to the Internet Protocol Suite. Internet refers to the wide area network and the bodies that govern the Internet. TCP/IP protocol suite is used in Internet today. Protocol suite is a set of protocols organized in different layers. TCP/IP model has various protocols in its 5 layers. These protocols are arranged hierarchically. These modules are interactive and each module provides a specific functionality. These protocols define the way information flows from layer to layer. These are the various layers that are available in the TCP/IP protocol suite. At the bottom layer, we have the hardware devices, followed by the network interface, then internet, transport, and application layer. Let's look at this diagram. Let us assume that computer A communicates with computer B. We have 5 communication devices in this communication. First device is the source, which is host computer A, which is connected to a link layer switch in link 1, and it is connected to a router. The router is then connected to a link layer switch in link 2, and this link is in fact connected to the destination host in computer B. As we saw in the last diagram, here we see different devices and each device is involved with a set of layers depending on the role of the device in the internet. The two hosts are all involved in all the 5 layers. The source host, that is the source A, needs to create a message in the application layer. Then send the message down to the layers so that it is physically sent to the destination host. The destination host needs to receive the communication at the physical layer and deliver it through other layers to the application layer. The router is involved only in 3 layers. There is no transport or application layer in the router as long as the router is used only for routing. A link layer switch in a link, however, is involved only in 2 layers, the data link layer and the physical layer. The data link layer defines the networking methods within the scope of the local network link on which the host communicate without intervening the routers. Now let's look at the physical layer in detail. Physical layer is responsible for carrying individual bits in the frame across the link. Two devices are connected by a transmission medium, and the transmission medium carries electrical or optical signals. The bits received in the frame from the data link layer are transformed into electrical signals and sent through the transmission media. Data is physically sent over the network. Devices connected here are repeaters, cables, and connectors. The protocols that are used in the physical layer are Ethernet, Bluetooth, Universal Serial Bus, which is USB, and Digital Subscriber Line, which is DSL. Let us look at this diagram. In this diagram, we see at the source side, from the data link layer, the data arrives in the form of ones and zeros to the physical layer of the source. In the physical layer, the ones and zeros are converted into electrical signals and they are transmitted through the medium. And the electrical signals reach the physical layer of the destination. And here again the signals are demodulated and converted into ones and zeros. And then again the ones and zeros are sent to the data link layer of the destination. Data link layer. Data link layer takes a datagram that it received from the network layer and encapsulates it in a packet called a frame. The communication channel that connects the adjacent nodes are known as link. In order to move the datagram from source to the destination, the datagram must be moved across an individual link. The main responsibility of the data link layer is to transfer the datagram across an individual link. The data link provides error control and framing. The devices used here are switches and bridges. Now let's look at the different protocols that are available under data link layer. We have three types of protocols available. They are noiseless channel protocols, noisy channel protocols, and random access protocols. Noiseless channel protocols have a simplest protocol. Under simplest protocol, we have a protocol called go back in ARQ protocol. Under noisy channel protocols, we have stop and wait ARQ protocol, go back in ARQ protocol, selective repeat ARQ protocol. Under random access protocols, we have Aloha, CSMA, CSMA CD, and CSMA CA. Under CSMA, we have one persistent and P persistent protocols. Next layer is the network layer. Network layer is responsible for creating a connection between the source computer and the destination computer. The network layer in the internet includes the main protocol, which is the internet protocol. It defines the format of the packet called a datagram at the network layer. Internet protocol defines the format and the structure of the address used in this layer. Internet protocol is also responsible for routing a packet from its source to its destination, which is achieved by each router forwarding the datagram to the next router in its path. Let's look at the different protocols that are used in network layer. Here we use Internet Control Message Protocol ICMP, Address Resolution Protocol ARP, Reverse Address Resolution Protocol RARP, Dynamic Host Configuration Protocol DHCP, Internet Protocol, and in Internet Protocol we have two variants, IPv4 and IPv6. Then we use Internet Protocol Security. Next layer is transport layer. The transport layer at the source host gets the message from the application layer, encapsulates it in a transport layer packet called a segment or a user datagram in different protocols, and sends it through the logical connection to the transport layer at the destination host. And transport layer protocol is responsible for giving services to the application layer, such as to get a message from the application program running on the source host and deliver it to the corresponding application program on the destination host. Now, let us look at the different protocols that are used in transport layer. They are User Datagram Protocol UDP, Transmission Control Protocol TCP, and Secure Socket Layer Protocol SSL. The last layer is the application layer. Communication at the application layer is between two processes, that is, the two programs running at this layer. To communicate, a process sends a request to other process and receives a response. Process-to-process communication is the duty of the application layer. Hypertext Transfer Protocol (HTTP) is used for accessing the World Wide Web (www). Simple Mail Transfer Protocol (SMTP) is used for email service. File Transfer Protocol (FTP) is used for transferring files from one host to another. Terminal Network (Telnet) and Secure Shell (SSH) is used for accessing files remotely. Now we are going to see the different addressings used in TCP/IP protocol suite. Also, the different packet names that are used in the different layers of the TCP/IP protocol suite. The four levels of addresses that are used in TCP/IP protocol are physical address, logical address, port address, and application specific address. The data created at different layers of TCP/IP model have different packet names. Let us look at the names of the packets created at different layers of the TCP/IP model. Applications are given user-friendly address that are designed for specific applications. Example, the email address, and the universal resource locator, which is URL. The name of the data packet created at layer 5, which is the application layer of the TCP IP model, is called message. If the protocol used at the transport layer is TCP, which is Transmission Control Protocol, the data packet is known as TCP segment. If the protocol used at the transport layer is UDP, which is called User Datagram Protocol, the data packet is known as UDP datagram. There are many applications running on the computer. Each application run with a port number. A port number is a part of the addressing information used to identify the senders and the receivers of the messages. These port numbers allow different applications on the same computer to share network resources simultaneously. A port address is a 16-bit address represented by one decimal number, for example 753. Internet Protocol encapsulates the transport layer data packets, which are TCP segment or UDP datagram. The data packet created at layer 3 or the network layer by the Internet Protocol is called as IP datagram. Logical addresses are used by the networking software to allow packets to be independent of the physical connection of the network, that is, to work with different networking topologies and types of media. A logical address in Internet is currently a 32-bit address that can uniquely define a host connected to the Internet. An Internet address in IPv4 is a decimal number such as 132.24.75.9. Layer 2, which is the data link layer of the TCP/IP model, may further divide and encapsulate the layer 3 IP datagram. The data packets at layer 2, which is the data link layer, is known as a frame. The physical address, also known as the link address, is the address of a node as defined by its LAN or WAN. Ethernet uses a 6-byte or 48-bit physical address or link address.